Hello, everybody, and good morning, good evening, good night, depending on where you are in the world. Just for a sound check, can you raise your hands if you hear me? Great, I'm happy to see that some of you are out there and paying attention. Actually, this is one of the biggest audiences we've ever had for a webinar, and that's really nice to see. The amount of you that are interested in this particular topic. So the topic of the evening is, or the afternoon or the morning, is Hadoop still delivering on its promise? My name is David Leichner, and I'm the CMO at Scream, and with me today is Arnon Shimoni, who's the system architect here at Scream. And we've had a series of webinars dealing with all kinds of topics. This one seems to be of great interest, and I'm really happy that we're doing it. And I think you'll be happy to see the deck that we've put together. Just for the sake of some housekeeping, what we generally do is we'll take a Q&A session at the end, and if you can send any questions that you might have via the question menu, which is probably on the right side of your screen, that would be really helpful. And what we'll do is we'll take as many questions as we can at the end, and this way we can go through the information that we have for you today, and we can basically start, I guess. It's a couple of minutes after 6, and I think we've got a pretty full house. So why don't we just jump right in? So as I mentioned, the topic is Hadoop still delivering on its promise? So maybe just a little bit about what it is that that we're hearing. Sorry about that. There we go. Okay. So first of all, a little bit about Scream, who we are. So Scream has been around for a couple of years. We are one of the leading GPU-based data warehouses out on the market today, and we'll talk a little bit later on about Scream, but maybe just very, very briefly. Today we have 70 employees. We've got 10 patents, over $40 million in funding, a very strategic relationship with the Alibaba Group in China. Our corporate headquarters are located in the 7 World Trade Center in New York, and our R&D headquarters are located in Tel Aviv. We have today customers all over the world, from the United States through Europe into the Asia Pacific region. So jumping to the first slide here. So what we are hearing. So you can see here that when we discuss the issues or the challenges facing companies today with Hadoop and whether Hadoop is still delivering on the promise, what we're hearing is that companies have been taking a lot of data and putting it into Hadoop file systems, file storage, and trying to get at that data, but they're only able to analyze between 10 and 20% of the data. We're hearing that the data is growing, both structured and unstructured data is growing at rates that we haven't seen before. And it's basically the insights that they're trying to achieve are coming from larger, more diversified data. And probably most importantly, that the existing systems are they won't scale from the point of view of being able to do analytics at the level of hundreds of terabytes, petabytes. It costs a lot of money. The resources, you started out with a couple of nodes of Hadoop. Now you're up to 100 nodes of Hadoop. So the resources that are needed in order to support the systems, either those resources are very expensive or it's very difficult. And one of the issues that we're hearing a lot about is it's very difficult to find those resources. So this is just, also on the area of scale, also in the area of being able to pull out the insights needed and to analyze the data, as well as, having the staff to take care of the exponentially growing data stores that are out there. So on the next slide, we see that first of all, the average time spent on data preparation, as you can see here. This is actually from the Gartner organization. By the way, I was giving a presentation in front of some data analysts at the DBTA event in Boston a couple of weeks ago, and one of the things that they mentioned to me was that I asked them, how much time they're spending, if it's true that they're spending 80% of their time on data preparation, and they told me yes, of course. The other 20% of the time they're spending complaining about that data preparation. And as you can see, so Gartner reports that 60% of their time is on data preparation, leaving little time for analysis. If you look at the InfoWorld report, most data scientists are spending actually only 20% of their time on data analytics. So what that means is that they're leaving a lot of insights behind. So on the next slide, you can see that what that means actually, and this is from an article that Kalev Taro had in Forbes recently on AI and big data, industry guru, you could call him, that the big data revolution will be sampled. How big data has come to mean small sample data. That means that organizations are just not able to analyze the amount of data that they need to. And that means that if we look at the next slide, we can see that, that the amount of data that they actually are able to analyze is, about 10%, and that 90% of insights is being lost. That means if we're talking about companies that are extremely data rich, which means they have these really large data stores of hundreds of terabytes, petabytes of data, they actually are not being able to leverage that data and to get the insights that they need. You can see here the analytic data, 10 terabytes in 100 terabyte data, only 10% is being actually analyzed. And as we grow into the 10 petabyte level, we're talking about 0.5% of the data that's actually being analyzed. And we look at the next slide, so we can see that when we're looking at what is the the detriment, what are companies losing because they're not able to analyze the data. Forbes had a really good article about this, and they said that just a 10% increase in data accessibility, just a 10% increase in the ability to gain insights out of the data for a typical Fortune 1000 company means that they're able to get an additional 65 million additional net income. And this comes from also the ability to better plan, better do customer segmentation, customer product segmentation. It could be that they're actually saving money based on inefficient areas within the business. There are many ways that they can use these insights, and you can see here that they estimate that 65 million. And the retailers who are able to leverage their big data, the full power, meaning they're able to analyze a lot of their data, they could increase their operating margins by as much as 60% because they're able to get the historical information, they're able to do trending, they're able to, again, understand their customers better, to be able to target their products better, and so on. So let's go to the next slide.
Right.
So Arnaud, and I think I'll hand over for you at this point, and we'll see a little bit more in depth about Hadoop.
Right. So we actually titled this presentation, "Is Hadoop Still Delivering on Its Promise?" And I think the answer to that is it depends, which is a really annoying answer, but that's the truth, right? It depends. It depends how it's being used, what it's being used for, because Hadoop is such a phenomenally large system, and it has so many moving parts. And some of them are still really worth your time, and some of them maybe less so. But I think it's important to understand why Hadoop even came to prominence. So when we're looking at around 2004, Google publishes their MapReduce algorithm. They put that out there. They say, this is what we're doing. And when Google usually puts out an algorithm, open sources it, it means that they're done with it, that they have something better. But in this case, MapReduce is actually a really solid idea. And at the same time, we're seeing the explosion of the web, and a lot more data is being generated and collected, and analytics becomes a really important part of a lot of businesses. Unfortunately, a lot of the databases that existed back then had trouble scaling because of a lot of workarounds that were built into them to get the performance right. So when these kind of workarounds or solutions started collapsing, we saw the rise of alternative databases, what was known as NoSQL. And Hadoop is definitely one of the big players in the NoSQL range. So this is a graph I found on some database. It's a little bit old, but that kind of gives you the mindset of what was going on around 2006-ish when Hadoop was coming into play. We would see, they were saying, the performance of NoSQL databases remains constant. Relational databases, they just can't handle the data. Now, this is true for 2000. It's not so much still, it's not really relevant today, but that was the mindset. And that's what Hadoop was designed for. And Hadoop is actually a really great idea. It's designed to store pretty much all your big data, and I put big data in quotes here, or single quotes, on cheap commodity hardware, where in reality, all of these kind of have to be in quotes because it really depends on the company. Originally, it was designed to, as I say, store big data on cheap commodity hardware. But as the requirements grew and developed, that kind of changed. So commodity hardware and cheap hardware, not so much a thing today in Hadoop deployments, but this is what we're talking about. This is the original idea. It was designed to solve the Google scale issues primarily for search engines. And when you look at the original Google paper about MapReduce, what they were trying to solve is kind of this word counting or figuring out n-grams, which is a thing that is used a lot in search engines. They were trying to figure out how they can do that more efficiently without having to buy one really expensive piece of hardware. So Hadoop actually deploys code to the data. So when you load data into Hadoop, you distribute it across several nodes. It can be, starting from a handful of nodes, and it can be hundreds of nodes. And what you do is when you want to run some sort of job or some sort of processing, you write a piece of code that works with MapReduce. So you're writing mappers and reducers, and you're deploying that to where the data sits. So rather than moving the data around, you're moving the code around, and you're deploying your code to all the nodes. You're running a process, and the idea is you get results from that. So this all sounds fantastic. It's part of the reason why Hadoop saw such an incredible uptaking. People loved it. People loved talking about it, and it looks like a fantastic idea. Unfortunately, for what we're talking about, primarily analytics, there are some issues with it. We call these pains. We can call these issues. We can call it whatever we want. The reality is, for some problems, what we call embarrassingly parallelizable problems, like counting words in a document, it's not really hard to do that with Hadoop. It's actually fairly easy, and that's fantastic. But for more complex kind of workloads, which a lot of analytics are, for example, a join operation, that's incredibly hard to do on Hadoop with large data sets, because you have to make sure that the data is local. Because if you're only deploying the code and you want to do a join, the data has to sit on the same machine. Otherwise, you have to start copying the code back and forth. So that immediately means that it's not really designed for like a join operation. And it actually struggles with structured data. It's really good for documents. That's literally what it was designed for. And it kind of struggles with structured data. So that would be our first problem with Hadoop. The second is, with all of its fairly unique ideas, it's kind of hard to use. It relies on what we call uncommon skills. Now, it's not extremely uncommon because you can find Scala programmers and people who know MapReduce, but doing it efficiently and getting the amount of people that you need to convert your analytics and really empower your people, empower your data scientists and your data analysts to get what they need and do it fast is unfortunately a little bit difficult. Even now with some SQL interfaces on Hadoop, they're a little bit finicky. They're still kind of, I'd say almost like a workaround. They're not designed to run on Hadoop. As I say, Hadoop is not efficient for structured data. And when you make Hadoop try to work with structured data, you end up with something that's a little bit fragile and maybe doesn't have the full coverage of features that you need. So it's still, unfortunately, a little bit difficult to use. And finally, Hadoop was not designed for analytics. It requires very careful management of data. You have to distribute data very carefully and very particularly, and you have to know a lot about what you're doing Otherwise, you're going to be ending up copying data around a lot and using it very inefficiently. So unfortunately, it's also not designed for analytics. The last part is it's a really big patchwork of different applications which serve different goals. They're kind of hard to deploy. This is not a specific pain for analytics, but it is a pain for companies dealing with Hadoop. It comes with a lot of different parts like Oozie and HCatalog and HBase and Hive and Yarn and Tez and Spark and Zookeeper and Pig, and it's built up on so many parts, and it's kind of hard to manage. So back to the question, is Hadoop still delivering on its promise? A lot of these components are. So HDFS, for example, absolutely a phenomenal piece of engineering that's super useful for when you're building a data lake. Yarn for the resource for the managing jobs, and I mean, some of these components work really well, but when we look at the entire ecosystem of Hadoop for analytics, the answer is maybe less, right? It's not delivering on its promise as much as if we look at HDFS, for example, or Spark separately. So this actually causes some barriers for analytics, because I mentioned you have to prepare the data very carefully, and you have to deploy all these different pieces of software. And what this means is when you're bringing in a new data source, you potentially have to take a lot of time, sometimes days and weeks of work to prepare a data set for analytics, to prepare the data set to be ingested into Hadoop, distributed correctly, partitioned correctly. You have to set up the tables very particularly. You have to make sure that it's perfectly distributed across the nodes so that you're not doing overly complex data transfers, in order to allow your SQL, your BI customers, the people who know SQL and who know how to write queries, to actually use that data, to make use of it. Now, this is quite a significant barrier, which means that there are some use cases that Hadoop doesn't address well. So this is kind of like a feedback cycle of things that hurt one another. So the first thing that we talk about is ad hoc analytics, primarily ad hoc SQL analytics. I mentioned that some of the people, or most of the people who actually work with data, they know SQL really well, but they may not know Scala. They may not know how to write MapReduce jobs, because sometimes problems are difficult to convey with MapReduce, or convey with like code that you write line by line. Sometimes you just want a simple expressive language like SQL to run your question. And Hadoop, unfortunately, as I mentioned, is not designed for that. It's not really good for that. So it doesn't address that problem really well. What that feeds into is it kind of takes the control away from data consumers. So it's not good at empowering the data consumers to run their queries and let them be the owners of the data. You want your business people, your data scientists, your data engineers, your analysts, you want them to be able to run whatever query they want. You want them to be able to focus on the data rather than the specifics of the specific Hadoop platform that you've deployed. And of course, every Hadoop system is different. Some may be relying on MapReduce, some have Spark, some have Kafka leading into Spark. And what do you use to query? Are you using Kafka SQL? Are you using Spark SQL? Are you pushing that then into Impala? Or there are so many different problems that come up with the patchwork of different applications that Hadoop is. And that feeds into what we call data consolidation that Hadoop doesn't do really well. When you have all these different applications and you have different data sources managed in these different applications and libraries, you end up with silos. You end up with silos of data. So today, maybe my manufacturing department has a set of data that I'm interested in, but it doesn't make sense together with my customer profile data. And I want to correlate these two pieces of data, but I can't, because they're stored in different formats in different systems. They're all technically in Hadoop. They're all technically stored in HDFS. But accessing these two disparate data sources is quite difficult and very time consuming, and it involves a lot of people having to work in order to make that happen. So that's the last thing that Hadoop doesn't really do very well, is the data consolidation. And that, again, feeds back into the ad hoc SQL analytics. So this is like a vicious, kind of like a feedback loop, or some sort of cycle which is never ending, because each one of these feeds into the next. So the question is, what can we do to help? And there was a clue at the beginning where we said Hadoop came to prominence because SQL databases and relational databases couldn't scale. So we propose our own database, the one that we've been building for a few years now. It is called ScreamDB, and it is built by design for massive data analytics. When we say massive, we mean usually tens to hundreds and even petabytes of data. And we've designed it with the data analyst and the data scientists in mind. So at its core, it is an SQL database. It uses the familiar ANSI SQL, and it uses the standard connectors to connect to everything around. We've also designed it to be as scalable as possible. What that means is we use extremely lightweight and performant methods to be able to, respond to SQL queries in human real time. And the way that we do that is with a GPU. So we actually rely on GPUs inside the database, inside our hardware, to be able to supply the extreme performance that we're talking about. So what we've actually designed is a database that's designed to offload the analytic workloads from Hadoop and other databases. It is a fully featured SQL solution that works on raw data directly. So it's not some sort of hybrid solution that attempts to make use of random files in disparate locations. This is a fully featured SQL engine that is designed to work on the raw data directly. And of course, it comes in a very small hardware footprint owing to the GPUs. We're able to make it so small and so efficient that we don't need hundreds of nodes. And I'll show you what that looks like in just a bit. So essentially what we're talking about is combining the best of both worlds, because Hadoop, as we said, is still delivering on its promise with distributed cost-effective storage. It's well established as a data lake. It's already deployed successfully in a lot of companies, and it is well integrated in a lot of processes. On the other hand, ScreamDB is scalable in both compute and storage. Unlike Hadoop, we can grow in storage and grow in compute separately. We have a high-performance SQL engine that lets you run ad hoc queries, which leverages the existing SQL skills that already exist in your company. And of course, that makes it extremely easy to use. And we've built in a bunch of features that make it even easier to use than other competing databases. So this is what a common deployment looks like for Hadoop. So we will have ScreamDB at the center, empowering the data scientists and the data analysts with ad hoc SQL queries, and it's also useful for reporting. And on the other hand, we can accept data coming from a variety of sources. It can be directly from, for example, Parquet files. It can be from your Hadoop system. We can load Avro files and Parquet files and Orc files, and we can load from other databases. So this is the idea, right? We're giving you a system to put your data into and run analytics on, instead of relying on the classic Hadoop stack. What we are essentially offering is a system that lets you grow to different lines of business with distributed compute and centralized storage. So every different line of business can get its own dedicated access to the data. So this way, there are no silos. If you absolutely want to, you can separate the data. You can say, I don't want the reporting users to see the BI data. That's fine. That's something you can do willingly. But by default, the system lets everyone access the data at all times. So even when you're adding new lines of business, or you're adding more servers because you've doubled your department size, then everyone can still access the same data. And it's super easy to use, and you don't have to redistribute the data. So what we're saying is we're actually delivering the Hadoop promise of scaling without the complexity. And as I've shown in the previous slide, we actually work alongside with Hadoop, and we rely on some of the Hadoop principles, including HDFS, to supply all of this performance and the scalability. So with that, I think it's best if we talk about a use case now of something that we've actually done with a customer that had Hadoop, or still has Hadoop actually. And this is a company called Pubmatic. They're a company out in the West Coast, and they're an ad tech company. And what they do is they provide a service for publishers and ad buyers and ad companies. They take real estate on websites, and they negotiate for people publishing ads, right? So this is a highly competitive business, and you want to charge the people who are running the ads. You want to charge them as much as you can, but you also want to get the lowest cost for that real estate on other websites. So it's kind of like a very delicate game of trying to balance, your customers with the people you're renting from. And this company is very big. They have trillions of ad impressions monthly, and they're looking at about 140 terabytes of raw data being generated every day. And basically, they have a data torrent and Kafka system which feeds into Hadoop. And their existing solution, their incumbent solution, was based on Apache HBase and Apache Phoenix. So they actually connected these two components together to give them kind of SQL capabilities on the data that's being stored in Hadoop. Unfortunately, it was kind of an unperformant system, I'd say, with some queries taking about 5 hours, sometimes a little bit more, sometimes a little bit less. But when you think about a person who actually has to run a 5-hour query, they come in the morning, they run a query, and they only get the results after lunchtime. And suppose they made a mistake, or they didn't think about the query to its full extent, and they want to rerun it. By the time they run it again, it's already, by the time they get the result, they're already home. So they had to develop this kind of weird roundabout situation to handle, to have the query time minimized, and they would let one person run it, and then another person would pick it up, and so on and so on. So they challenged us, and they said, what can you do? What can you help with? So we came in and we brought our solution, ScreamDB. And for the initial project, we used just a couple of NVIDIA Tesla GPUs. And what we were doing is we were actually loading the data from Avro directly from Hadoop into ScreamDB, and we showed them that the queries can take just about 5 minutes. So 5 minutes versus 5 hours is a really, really big difference for when you have to run a few queries, or when you're reliant on the results to optimize what you're doing. The result from this initial project was they were actually using ScreamDB to store all of the bid and yield data. What that did is, with all these queries that they were running, they were trying to optimize their earnings. And by looking at more data than they were otherwise able to look at, they were getting better accuracy. And better accuracy translates directly into better yield for these ads. So instead of making $10 for an ad, they're now making $12 or $13. Now that doesn't sound like a big difference, but it is when you look at the macro scale, and you're looking at trillions of ad impressions. A tiny difference in the accuracy there results in a lot of money being generated. You can look at it as money being saved on the one hand from the companies and the websites that they rent the data from, but also new money being generated that wouldn't otherwise be there from their customers, from the people publishing the ads. So all of this was actually done in order to leverage the existing SQL knowledge. So they were, as you see, they wanted to use SQL. They were already using Apache Phoenix, but that wasn't working out for them because of the huge amount of time it took to run the queries. So once again, we're sticking to SQL rather than writing custom scholars, custom MapReduce code. With this actually came a growing appetite for more data. So what they said is, let's grow from 85 terabytes to 360 terabytes. Let's stop cutting down on the data. As my colleague David mentioned, a lot of companies cut down on data. They cut down on data because the systems can't handle it. Now, Hadoop can handle storing all that data perfectly fine, but the tools that you use down the line, things like HBase and things like Phoenix, maybe are less inclined to deal with huge amounts of data in the same way. So we talked about 85 terabytes of data. Running a query on that would take about 5 hours. But when we're talking about quadruple the amount of data, the queries just would not run. We don't know how long they would have taken. They just didn't finish. The processes would be killed a lot before they would even have a chance to finish. Because when you wait for more than 2 days for a result, you get really anxious, and you think, okay, maybe something's wrong. Because of the way that ScreamDB organizes data, and because of how we collect our metadata and all of our software internals, the queries still took about 5 minutes. And this is not a mistake. And this is not because we've quadrupled the amount of GPUs. That was actually done for a different reason. The initial project had a couple of NVIDIA Tesla GPUs. The increased project had 8, and that's actually to support more users and not necessarily to bring the query time down. But what we're looking at here is this increased appetite caused more people to want to use the system and more data being fed into ScreamDB in order to run the queries. So we've actually grown from 85 to 360 terabytes. And this is the best of both worlds because we're still reliant on Hadoop. And Hadoop is still used for the data collection, and it's used for other applications as well. But the analytics is being run inside ScreamDB. So this is actually about selecting the right tools for the problem at hand. So that's pretty much it about PubMatic. But I want to summarize with the value of ScreamDB, of what value we brought to this customer. The first is the Adhoc Analytics at scale. We're letting them make better business decisions. We're letting them optimize their processes and bring in new money with a fully featured SQL database. They're getting more and new revenue streams from the increased insights. And of course, and this is the most important to me as a database user, they're empowering the data consumers. They're simplifying the procedures. They're cutting down on weight, and they're increasing employee productivity and happiness. Because if you're not waiting 5 hours for a database to return your query, and if you can, get to your work faster, you're not just sitting there wasting your time, you're happier, you're more productive. So we think you should make the most of your Hadoop investment. If you already have Hadoop, you should absolutely keep it. You should use it for what it's designed for what it's good for. You can combine it with ScreamDB to get the economy of Hadoop with the performance of ScreamDB. We urge you to use SQL. SQL is expressive. It's super well defined. It's based on a solid mathematical principle. It's used by everyone. A lot of tools know how to use it. Tableau, Spotfire, Qlik, Power BI, all these tools know how to generate SQL. So we say, use these tools, rely on them. There's a reason they're still around after 50 years. And of course, fast, performant, and scalable data analytics with ScreamDB. That's what we're talking about. So to summarize, is Hadoop still delivering on its promise? Some parts, absolutely. Some parts, not as much, but we can still maximize the investment in Hadoop by combining Hadoop with other technologies that do scale really well. And with that, I think we're ready for the Q&A, David.
Great. Well, I saw there are a couple of questions actually that have come in, and anybody else who wants to ask a question, we've got about 10 minutes that we can, actually a little bit less, we can answer a few questions. So one of the questions that came in was how much data can Scream actually handle? How much, to what degree can Scream scale? Is it for terabytes, petabytes?
So the software itself doesn't have a hard limit. We've tested up to about 1.5 petabytes. Theoretically, there's no problem to scale further. I actually have a slide for that. Hold on, let me find it. This is a slide that talks about how we actually are able to scale. We have an internal process called hyperpartitioning, where we take the data and we split it up into columns. So that's a very common thing in analytics. A lot of databases split the data up into columns. But then we further split the data down into small manageable chunks. Now, a database can have billions and billions of chunks, and each chunk can represent, 5-10 million records. So there's no really hard limit here that we're experiencing. It depends on the use case. Of course, there will be some situations where we won't want to grow over just a few petabytes. There will be some situations, and there's a customer we're actually working with right now that's looking to do 22 petabytes. We're in the implementation phase of that one, and hopefully we'll be able to share something at some point.
Great, thanks very much for that. Another question was, how fast is it to move data from Hadoop to Scream, and how is the data actually updated once it's in Scream?
So Scream is a database like any other. We need to get data in, and that depends on where you're reading it from. For the most part, ScreamDB is usually not the bottleneck. We can do loading at about 3.5 terabytes per hour on a single GPU on a single node. So more data and more GPUs and more nodes means we can look at ingesting more data faster. It's going to ultimately depend on the source system. Something we've seen in the past is usually the source systems tend to be the slower systems. So it's going to be highly dependent on the customer, unfortunately, and how they've set their system up.
Right. Okay. By the way, you said Scream is a database like any other database, but it's not actually, is it? I mean, actually, one of the questions that came in was why use Scream instead of one of the SQL engines that works with Hadoop.
Okay. So we are a database. When I say a database like others, I mean in the sense that we need to load data in, like other databases, and the interface will be the same, right? So we support the standards like JDBC, ODBC, and we support the standard files like others do. And you would still need to go through that process. Of course, we've seen our loading process, and we know it's very, very fast. It's very fast compared to pretty much any other database that we've ever had to compete against or ever tried. And that's something that we've been optimizing for a long time. Why would you use ScreamDB versus an SQL and Hadoop system? So that will depend on how complex your queries are and how well your system is engineered. It is possible that when you launch like an SQL and Hadoop system, you're just looking to peek at some Parquet files or some Avro files, and that's good enough for you. And in that case, by all means, that's the better choice. But when you actually want to rely on a database that has permission, like solid permission control, object level roles and permissions, and you want to have the data secure and what we call ACID compliant, you want to make sure that no one's touching your file and by accident all the data goes away, then you kind of want a database rather than an SQL engine. And of course, there's the added benefit that when you load data into ScreamDB, we actually format it, we store it in a very particular way. The chunking and the columns that we see here are part of it, but we actually collect a lot of metadata as we load the data in, and we prepare it to be analyzed by the end user. So we're doing a lot more than just looking at a Parquet file and saying run a query on this. This is a fully featured database, and it comes with all the features that you would expect from an SQL database.
Got it. Great. The next question actually that just came in, and I think the answer that you're going to give is it depends. And that question is, can Scream replace Hadoop for big data?
Unfortunately, it depends, right? No, sometimes, because it depends, once again, on how Hadoop is used. So if everything is a MapReduce process, for example, and it's been finely tuned, then you could, but why would you, right? If everything is absolutely finely tuned and works and is performant and answers all your desires, then could we replace? Yes, but would you? Probably not. It can replace,
or you might want to incrementally migrate into Scream, depending on how much you're spending on resources. That's one.
Yeah, that's absolutely one of the options. Another thing is if you're doing, for example, unstructured data, if you're looking at photos and video, then Scream is not a good choice for that. But if your data is semi-structured or structured, then we can absolutely provide a lot of value for that. And it's something that we've done before. And we showed Pubmatic here a little bit earlier. In Pubmatic, we were actually converting semi-structured data into structured data in the process in order to be able to analyze it a lot better. Because in semi-structured, sometimes you have like nested objects and things like that, which don't work really well. It's more like a schema on read. What happens is every time you want to access that piece of data, you have to do that conversion. And when it's a small scale problem, when you have Hadoop, it seems like a non-issue. But when your problem set gets big, then you start paying a heavy penalty for that. So that's the reason, by the way, why at Pubmatic we did that conversion. And let me go back to that slide. That's why we did this conversion from semi-structured to structured. It made our queries a lot faster. That's another thing to look at.
Great, excellent. Last question I think we'll take, and then we'll wrap up, is how can someone who's interested get started with Scream? What's like the process?
Yeah, so you reach out to us and we'll be happy to demonstrate it for you. We're very familiar with a lot of use cases. We tend to like to show it in-house. So, for example, if you want, we can come into your company, bring ScreamDB. We can run it in the cloud. We can run it on your data center. We can bring a server with us to show it, or even like a small desktop server to show it. And we can show it on your data, so we can show you what the value is for you. Otherwise, if we can show you TPCH benchmarks, but those are very generic, and I don't think they cover a very wide set of issues. What we like to do is we like to show customers the value on their own data, and it's something that we can do in a matter of a few days. And then it's up to you if it's interesting to you, if it solves a real problem for you. Then we would continue and we could talk about a full deployment. And if not, then no big deal.
All right, excellent. Well, Arnon, thank you very much for that, and thank you everyone for attending. It's been a very interesting session, and keep posted. We're continuing our webinar series, and we'll have one in a few weeks, and we will post it and send it out to you. And we look forward to having you with us again online in a few weeks. Have a great morning, afternoon, evening, depending where you are in the world. And here I'm looking out at the Mediterranean Sea. It's beautiful, and it's beginning to get to the point where the sun will be going down. And I hope you guys are all in a similar type of area and similar type of scenery. And I wish you a wonderful summer as well. Thank you very much.
Thank you. Bye-bye.